All right, here we go. Let's clear our calculator. Second plus 712. Clear your calculator. And now we're going through the study guide. The first the first 10 problems are calculated inactive. Somebody's still talking. At the top of this paper, I'm going to put this is our study guide. So we got study guide. All right, and this is number one. The first one, it says, the first one, it says, the Smith family purchased a home in 1950 for $25,000. The value of the home increased, okay, approximately 3.5%. If it increases by a percent or by a common ratio, it's an exponential function. And since it increases by a percent, this is an exponential function. It increases, so that means it's exponential growth. Yes. It's on the stand over there. Okay. The value of the home increased by 3.5% per year since. Which function could represent or which function could model the approximate value of the home since that starting year? Okay, so we know that it's an exponential growth. So it's y is equal to c, parentheses 1 plus r to the t power, or x. Our starting amount or our starting value is the 25,000. Okay, guys, please make sure that you're listening. Please make sure that you're listening, you understand, because we do have a test. What's wrong, baby? What you need? Don't. Just stop looking. Here. Stop looking. Use this white piece of paper. Let's sit this way. Okay. Anybody else need one? All right. One is 100% written as a decimal, plus the percent, the R is 3.5%. To change 3.5% as a decimal, you move the decimal two places to the left. So when you move it two places to the left, that's going to equal 0.035. So we're going to plug in 0.035 for R. Okay? And X number of years, or T years. This is the equation that we should be looking for. What letter choice is that? That is letter choice C. All they did was add these two together. That's letter C. So I'm going to put letter C as my answer here and box in my word. Number two. Okay. And I'm actually going to put number two over here to save myself some space. Number two says the population of bacteria. Raise your hand if you got number one right. Good. The population of bacteria after X number of hours is modeled by this expression here. Okay. What is the rate of decay? And we know it's decay because our B is less than 1. And that's our B there. So we got our B in this problem is 0.75. And we want to figure out, fold this paper, and we need to figure out what the rate of decay is. So we use the formula B is equal to 1 minus R. So to find the R of the rate of decay, we substitute B in the place, we substitute 0.75 in the place of B. Now to find R, what do we do to find R to get R by itself? Subtract 1. When we subtract 1, this gives us a negative point what? Very good. Bring down the negative R. So to get rid of a negative that's in front of the R, I'm either going to multiply or divide both sides by a negative 1. And that gives me a positive 0.25 as my rate of decay, or 25%. Remember, you move the decimal 2 times to the right, and that's going to be either 0.25 as a decimal or 25%. What answer choice is that? That's A. So I'm going to put A on my paper, and I'm boxing in problem number 2. Raise your hand if you got 2 right. Okay. Number 3. Stop me if you have questions. Stop me if you feel like I'm moving too fast. Please stop me. Okay. The expression, this is 502 to the x power. We got 502 to the x power. We already know this is the starting amount. This is our common ratio because it's raised to the x power. This is an exponential function. It says can be determined. You can use that equation to determine the size of the population that grows over a period of time. What does this 500 again represent? This the starting population. So look, let's look for that. It's not the final size of the population. No, that would be y. That's be what it's equal to. The initial, yes, it's the initial size. Your answer here is B. It's the initial size of the population. I'm gonna read the other choices. The amount of time. No, it's not T, the amount of time. Okay, or the amount of time it takes to double. That's this right here. That's your common ratio. It's not the rate. That's finding the percent. It's not in neither of those. The best answer is going to be B. So I'm going to put B here and box it in. Raise your hand if you got that right. Okay, good. Almost everybody. Great job. Number 4. Cindy invested. This is the investment right here. We're talking about money. $2,800. This is the function. The $2,800 times, in parentheses, 1.025 to the t power. This is exponential growth because B is greater than 1. It models the value of her investment Y months, okay? So look at this one. That's the first function. The second function, the function ST, that's a separate function, still Y equals 10t. This is linear. This is exponential, and this one is linear. Models the amount of money that Sydney saved in her safe at her house. So she's saving money in 2 different places. Which function models the combined amount? So you just want to add those amounts together. So let's take the first amount. We got 2,800 times 1.025 to the x or t power plus 10t. And I need to use t and not x, okay? All right. When you add these amounts together, there's nothing that you can combine together. You cannot add any of these together because none of these are like terms. So this is the answer that you should be looking for when you combine those amounts together. Which letter is that going to be? D. That is going to be D. Okay? So you should get answer D. Please make sure that you have shown your work. Okay? Number 5. Any questions about these? Did anybody get this on their own with no help? Okay? Only a couple people. All right. The club began with 3 members. So the starting amount is 3 members. Each month, each member brought 1 new member. Okay? So that's 2 basically. It's doubling every single time. You and then somebody else. Okay? And that person and then somebody else. So you're here, you're not just adding, you're multiplying. So this is a exponential function. So you can eliminate the linear ones. So now you're looking at is these 2. So the starting amount is 3. That's going to be D right here. We know the common ratio is going to be 2 because it's you and somebody else that's being added every single time. It's doubling every single time. The starting amount is 3. So your answer for number 5 is going to be D. Did anybody get D? Okay, very good. So number 5, you write on your paper. Your answer for number 5 is D. Okay? Any questions? All right. Number 6. Number 6 looks like this one. It says the graph below shows the value of Matt's car over a 10-year span. Okay, so over a 10-year span. That's what it shows. Bless you. The domain, it says, what is the domain? That's the x values. These are the x values right here. It says, what's the domain of the function that best represents the value of the car in respect to number of years? So it's saying all integers. Integers is your negative and positive numbers, but they don't have decimals attached. So integers from 0 to 10 is 1, 2, well, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It doesn't include the half years. You can have half of a year. So we don't want to use integers because it doesn't represent where you can have half of a year. Okay? And you in the graph, you can see that it's being displayed. Half, 1.5, 1.25, all of those is being displayed. So you don't want to use all integers, just integers alone. So mark that out and mark this one out. Okay? So now we're looking at these two answers. We're talking about domain. And this problem is talking about a 10-year period. So it's going from 0 to 10, not from 0 to 2,000, I'm sorry, to 25,000, but from 0 to 10. So it's all real numbers from 0 to 10. The X or the domain is from year 0 to year 10. C is the best answer here. Did anybody get that right? Okay, a couple people. This is number 6, and the answer is C. Are there any questions about that one since a lot of people got that wrong? Okay. Number 7. Which graph best displays the starting population for 30 cows? So the starting amount is going to be 30 cows, okay, that are doubling every 5 years. So it doubles every 5 years. So which one is going to display that? First of all, since it's doubling, it's going to be an exponential function. It's going to be a curved line. It's not going to be a straight line. So I can eliminate A because A is a straight line. It's starting at 30, but it's a straight line. So you can't do that one, okay? This one, it starts at 30 right here, and it's a curved line. Possible answer. Okay, is it doubling though? So in 5 years is right here. Look at this. It went from 30 to 60. So this is a possible answer right here, okay, because it did double. Let's look at the other ones. Wrong way, Miss Reyes. Wrong way. Okay. This one is not starting at 30, it's starting at 0. So this is not a right answer. And it's a straight line. This again is starting at 0 and it's not starting at 30. So D is not a good answer. So the best answer is which one?
B.
Is B. Anybody get that one right? Okay, good job. Okay, a lot of people got that one right. So number, what was that? 8? 7? 7 is B. Okay. Let's look at number 8. Okay. Number 8. Suppose a certain type of bacteria doubles. So again, this is an exponential function because it's doubling, but it's doubling every 30 minutes. Okay, so it's doubling every 30 minutes. During each 30-minute period, it's approximately a little bit, 1/10 of the total dies. So after it doubles, a little bit of it dies. So we need to read the graph to see which one is going to be the best answer. Okay, so it doubles and then a little bit dies. Okay, so let's look at the first one, A. So it starts at 10 and it doubles. But look, it's just doubling. Not a little bit died here. So A is not our answer. Okay? Look at this. It doubles. That's all it did, but not a little bit died. Okay? So B is not our answer either. Wrong way. I keep flipping it the wrong way. Flipping it the wrong way. All right, let's look at this one. This is doubling, and a little bit looks like a little bit did die. And is this every 30 minutes? This is halfway between 0 and 1 hour, so that is 30 minutes. So this is a possible answer. Let's look at this one. it doubled here and went down a little bit, but look, at an hour. So this is not the correct. It looks like it could be the correct answer, but remember, it's going for 30 minutes and not an hour. So we can mark this one out. Our best answer here is going to be C. Any questions why C is our answer? Number 8 is C. All right, number 9. This is one a lot of people struggled with. Your A1, your first number in the list is 10. So watch Miss Reyes do this one. It's number 9. I'm going to draw X and Y. My first number, not my zero number, but my first number is 10. Okay? Then it says, look, it says 3 times A sub n minus 1. This A sub n minus 1 is just saying, n minus 1 is saying, I did not start with the zero number. I started with the first number. That's all this is saying. So then what is it saying that I need to do? You see how it says 3 times whatever the number is, n minus 1 is? It's just saying multiply each number by 3 to get to the next number. So in order to get to the next number, I'm going to multiply by 3. So I start with 10. Well, my first number is 10, not my zero number. So my second number, when I multiply this by 3, what is this number going to be? 30. When I multiply 30 by 3, what's my third number going to be? 90. Okay, how far do they want us to go? To what term? The fourth. Okay, so we're on 3 now. So I multiply 90 times 3. What's my fourth number? 270. Bless you, baby. So my fourth number is going to be 270. Did anybody get this right? Oh, that's good. That's real good. So our answer here is D. Our answer here is going to be D. Okay? All right. Everybody's okay? All right. Number 10, I'm not 100% sure what it's saying, but I'm going to write out what I think it's saying. And if the answer's not there, we'll be okay. At least we know how to do it. So here we got 3x, I think that's to the 4, y to the negative 4, divided by 6x, looks like to the negative 2, y, it looks like to the 6. It looks like it's to the 6, okay? I'm going to roll with that. If it's not there, that's okay. We just need to know how to do it. All right. So first things first, do what's in the parentheses first, okay, before you do this. So let's reduce this fraction, 3 over 6. What's 3 over 6 reduced as a fraction?
Half.
1/2. So we got 1 on the top, 2 on the bottom, okay? Then let's deal with our x's. When we're dividing, what do we do with our exponents? We subtract them. So this is x, and I'll put this out to the side. That's 4 minus a negative 2. What's 4 minus a negative 2?
6.
So this is to the 6th power, okay? Now let's do our y's. This is y, negative 4 minus 6. What's negative 4 minus 6? This is negative 10. Good job, okay? And that's what we have so far. Okay, so now to make this well, actually, I can just go ahead and multiply everything by a negative 1 exponent. So let's multiply everything by negative 1 exponent. I'll put a 1 here for this exponent, 1 here for this exponent, okay? So let's do it. Bless you. So this is going to be a negative 1 times a positive 1. That gives me 1 to now the negative 1. This is going to be negative 6. This is going to be now positive 10. And this is going to be negative 1. Okay, so now I've distributed that. So now to make exponents positive, I moved, if it's on the top, move it to the bottom. If it's on the bottom, move it to the top. Okay, so this one is a negative. This one's also a negative. So I'm going to switch it. This goes down to the bottom to make it now positive. This goes up to the top to make it a positive. This goes down to the bottom, make it a positive. This stays where it is because it's already positive. So my final answer, I don't know why I keep it in parentheses. That's okay. So my final answer here is 2y to the 10th power over x to the 6th power. This is my answer. And I don't think that's down there. Because that's probably not the numbers. It's not the numbers. Oh, well, I read the numbers wrong. It's okay. I know this is the answer. Okay. Any questions, comments, or concerns? You want me to wait right here? Okay. Okay, let's do the next one. We did. All right, so now we're on calculator active. What is with my paper that I just keep going the wrong way? Oh, you know what? I must have did these in tutoring. That's why this sheet looks like that. Did I write on this one too? I don't know how many times I did this for somebody. So I wrote on both of those. I did them a bunch of times. Okay, yeah, this is a cool one. All right, so what are we on? 11 now? All right. Yeah, I must have used that one in too long. All right, here we go. All right, so this one says a certain population of bacteria doubles, okay? And it's doubling every 60 minutes, okay? So every hour is doubling. It says beginning with, this is the beginning, 50 bacteria in the culture. The population can be represented by, and they give you this right here. The starting population is 50. This, our common ratio is 2. Where A is the number of bacteria after T number of hours, okay? Which is the appropriate domain? Those are your X values, okay? Your X is your T. That is the time. Your time, 60 minutes, 1 hour. All right. Is it all real numbers greater than 0? Could be all real numbers because you can have 30 minutes or you can, I mean, it'd be all real numbers. It wouldn't be integers because that's just going to give you 0, 1, 2, 3, 4. And you can have a decimal for minutes. You can have half of an hour. You can have 45 minutes, 20 minutes, whatever. So you don't want to use integers. So it's between these two. So is it all integers that are greater than 0 or is it all integers that are greater than 50? Which one's the best answer? A, okay? All real numbers that are equal to or greater than or equal to 0. You don't want to just start at 50 because then that leaves out all these other. That leaves out the 60 minutes. That leaves out 2 hours, 3 hours, 4 hours. So you want to do this one. So 11 is A. Number 12. Which statement justifies why this ordered pair 2, comma 1985.5, which is going to be y, is a solution, okay? All right, this is an equal to, so it's a solid line. So if, let me draw this, your line is going to be curved. Any point that's on the line is going to be a solution. If it's above or below the line, it's not a solution. So let's read the answer choices. A says the ordered pair lies on the graph. Yes, this is a good answer. If the ordered pair is on the line, it's a solution. Okay? The ordered pair lies below. No, if it's not on the line, that is equal to. If it's not on the line, it's not a solution. So B cannot be the answer. C, the ordered pair lies above the line. No, it has to be on the line since it's equal to in order to be a part of the solution. And D, the ordered pair is not a part of that doesn't make any sense, okay? No. The best answer here is going to be A. Did anybody get that right? Okay, good. All right. Any questions? 13. All right, here it says the treatment of the feline hypothermidism involves a single dose of radioactive iodine. The amount of radioactive iodine remaining following the treatment is shown in this table right here. X is the number of days, that's always time, and Y is the amount of radioactivity. Okay, so look, what do they want to know? They want to know about how much radioactivity will remain after 20 days. So you can't tell what the common ratio is because it's not going up by 0, 1, 2, 3. It's skipping days. So you have to type in the calculator. You have to type this in the calculator to get the equation. Okay? So where do we go to type in table values? No, y equals is where we type in an equation. We need an equation. No, second graph, there's no table there. Stat edit. Very good. This is where you go to type in the table values so that you can write the equation for this. So you got 0. Please make sure you're doing this so you'll know how to do this on your test. Then go over. You have 3. You have 1.5. And you have 0.75. Make sure that you type the numbers in. Any questions? Remember, I went to stat and I pressed enter on edit. I put my X values, bless you, in L1, my Y values in L2. Okay, so now where do I go so that I can get an equation for this exponential function? What button do I press now? What'd you say? Second graph? No, that doesn't give me anything. There's no y equals. I didn't type in an equation. I want an equation for this table. So let me go back. Okay. I think somebody said it. Can't be so sure. Stat, and then you go over to calc. Then where do you go from there? EXP, right? Yes. Expo reg. And now I want to be able to view my function table. So I need to type in second 1, comma, second 2, comma, what comes after that? Vars, then what? Y vars, and then what? Enter, enter, enter. So now this equation is under y equals. And so now I can see what's remaining after 20 days by looking at my table. How do I go and view the function table now so I can see the rest of the values? Second graph, somebody said. Good job. So you see right here is 0 and 3. That's in the calculator. If I go down to 8, you see how it skipped all those days? 8 is here. See how they skipped all those days in between? And if I go down to 16, you see how they skipped all those other days in between? So we want to know what is it after 20 days. Remember, you can always go here and type in 20 and it'll take you right to 20, okay? So here at 20, or you can keep strolling down. At 20, it's going to be point what? And what's the best answer from the answer choices? It's C, okay? It's C. And that's 0.53 and some change. Okay? Any questions? All right, let's look at number 14. Number 14, it says, which equation would intersect with the exponential function? And this is the exponential function right here. And it has these 2 points. So we need to write a linear equation. Okay? So in order to write a linear equation, 2 things you need. You need M and you need B. Okay? Remember, this is the M of this function. This is the B. This is the M. This is the B. This is the M. This has no B. The M is the number that's in front of X, which is 1. So let's find the slope to see if one of these slope matches, because all the slopes are different. So we can find the slope or we can type it in the calculator. So What is the formula for slope? No, that's slope intercept form.
y2 minus y1 over x2 minus x1.
Very good. Okay, this is the slope formula. What you gave me was the slope intercept form. Okay. All right, so let's use these 2 points. This is x1, y1, x2, y2. What are we going to put on the top? What minus what?
27 minus 1.
Okay, we got y2, so that's 3 minus what?
27.
3 minus 27. Go ahead, baby.
Can I go back to this? Can I go on this piece over start real quick?
Yes, sorry, she's not cussing me out. All right. What about the bottom?
1 minus 3.
1 minus 3.
1 minus 3. 1 minus 3. Okay. And so then what does that give you? What's 3 minus 27?
Negative 24.
Negative 24 over what number?
Over negative 4. Negative 2.
Negative 2. So a negative divided by a negative gives us a what? A positive. And what does this give me? A positive what for slope? So which one of these have a positive 12 slope?
B.
B is your answer here. All the slopes are different, so it's got to be that one. Okay, so your answer choice is B. Yes. Yeah, I can. I'll pause, baby. All right, number 15. A computer company is currently earning 400 in profit a week and predicts its profit will increase by 5% each week. Okay, so this is an exponential function because it's increasing by a percent. Okay, increase or decrease by a percent is an exponential function. All right, and this is every week. Okay, a second company, so it's comparing two companies. A second company is currently earning 900 a week and predicts that its profit will increase by 2%. So we got two different equations here. So we're going to write two different equations. Let's look at the first one. All right, what's the starting amount of the first equation? This is 15. 400. So we got y is equal to 400. And we're using 1 plus r because it's exponential growth to the x power. So what's my r in the first equation? What's my r? 0.05. So we're going to put 0.05 here. And this is our first equation, 0.05. So this is y is equal to, press down too hard, 400, 1.05 to the x power. This is the first equation. So let's do the second equation, okay? What's the starting amount of the second equation? It's 900. And we're using the same, because it's exponential growth, it increases. So that's 1 plus r to the x or t power. What's my r for the second equation? 0.02. Very good. So we're going to plug in r. We're going to put 0.02 here. Okay. This is 0.02. So this equation is 900 parentheses 1.02 to the x power. Any questions about how I got these two equations? No. So now we're going to type these in the calculator, bless you, so you can see when are they the same, okay? When are they going to be same? How long does it take for the companies to be the same amount of profit when their Y's are the same? Because Y represent the total profit, okay? That's what Y is. So let's type the equations in. Where do we go to type the equations in the calculator? Y equals. I'm going to clear my calculator. And now I'm going to go to y equals. Okay? Now I'm going to go, bless you. Now I'm going to go to y equals. So let's type this in. The first equation. 400 parentheses 1.05. Then we got caret key x. So that's the first equation. And you can use time. You don't always have to use parentheses. I just use parentheses, okay? And then the second equation is 900 parentheses, you could put times there, 1.02, close the parentheses, caret key x, Please make sure that you type it in correctly, because if you miss one part of it, that's going to throw the whole thing off. Okay? Any questions about typing it in? Anybody struggling with that part? Okay? Hold it up so I can make sure everyone has typed it, just to make sure that we got it. Good job, babe. Hatcher, type it in, please. Javier, type it in. Very good. Orlin, type it in. All right, good job, Cameron. Good. Gary, type it in. Good job, baby. Good, good, good. Very, very good. Come on. Very good. Type it in. Good, guys. Come on, type it in. Do you not know how to type it in? Don't you know how to type it in? Okay. Very good, Orlin. Very good. Sammy, you got it? Good.
I'm doing it.
Okay. Do you have it yet? No?
Yeah, I got it.
All right. So now, where do I go to view the function table? Second graph. So now we're going to look to see at how many weeks it takes for them to be at the same amount. Now, instead of strolling down to see if these weeks will work, you can press second window and you can go to X and you can type in those X values. So I can just switch it to X, or I can stroll up and down at the table. It doesn't matter. And then press second graph, and now I can type in 4 and see they're not the same at 4. Then I can type in 6 weeks, enter. They are not the same at 6 weeks. And I can type in 18, enter. They are not the same at 18 weeks, and I can type in 28. And I notice that they are the same or they're like $2 off, but basically the same at 28 weeks. Any questions about how I got D as my answer? So on my paper, I write what's that, 15? 15, and my answer for 15 is D, 28. Number 16. Sixteen says, in 1962, the average cost for 1 gallon of gasoline in the United States was 32 cents. That's pretty cheap. I wish. Okay. The cost of gasoline increased in average, so it's increasing by 1%. That's the exponential function. 3%. Okay. So I can use the formula for exponential function, which is going to be y is equal to c parentheses 1 plus r to the x or t power. Okay. This is number 16. All right. So what's going to be, and they want to know what is the average cost of gasoline in this year right here, 1972. So let's write the equation first. What's the starting amount of gas in this problem? 31 cents. Okay. And this is the starting year, and it's 31 cents. So my C is 31 cents. You're used to seeing a small number. You're seeing a large number, not a small number. 1 plus, what's my R in this problem? 0.03 to the x power. Okay? So now the equation is going to be y is equal to, I'm just simplifying, 0.31 cent, parentheses 1.03 to the x power. So now they want to know what's going to be the total amount in 1972. How do I figure out what the amount is going to be in 1972? Very good. What's the years from 10 years. From 1962 to 1972 is 10 years. It's the starting year, and it's 10 years later. So we're going to plug in 10 for what letter? X. So we plug in 10 here. And remember, we could use the calculator to do this too. Okay, because this is calculator active. We could have typed this in, but that's a lot of work when all you got to do is just type this line in. So let's type this line in. This is 31 times 1.03 and then caret key to the 10th power. And how much money is that going to be? That's going to be about 40, how much? About 42 cents. And what answer choice is that? That's C. Did anybody get that on their own? Oh, good. Yeah, that's really good. All right. Anybody still copying? And I'll just stay right here for a second. Is that anybody? Cooper, do you have it yet? Yes, no, maybe. Are you ready? You good? Okay. All right. It says a tournament begins with 64 players. Half of the players are eliminated, okay? After one round. Place the numbers to complete the function. So we're going to put these numbers where they belong. It was kind of easy, this one. All right, so which of these numbers are we going to put right here? 64. Okay, so this is number 17, and this is f of x, or you can put y is equal to 64 is the starting amount. And then what number do we put? Which one of these numbers we put here? 1, because that's basically a part of the formula. Minus, since it's decreasing, right? And what is it decreasing by? 0.5 or 1/2. Okay. To the, what letter did they use? X. So that is what you have to write for number 17. Any questions about that? Okay. Anybody still copying? 18. All right. Geometric sequence. Here again, the starting, they don't give you the zero number, they give you the first number. So watch me do this again. This is X, this is Y. The first number is 4. Not the zero number, but the first number in the list is 4. So only thing that n minus 1 is saying is that you're not starting with the zero number, you're starting with the first number. That's why they got n minus 1. Okay? They will put just n if you're starting with the zero number, but you're not. So you're multiplying by half every single time. So what's my next number going to be if I'm multiplying by half? It's going to be 2. Next number. Half of 2? 1. And so on and so forth, okay? I'll finish this up and give you the answers later. So I'm going to finish it up. We'll make our test on Tuesday instead of Monday. Okay. Okay, so at number 18, I'm going to read it again. This is a geometric sequence. When it says a sub 1, this is not the zero number. This is your first number in the list. So what you do is you make an X and Y. Start this over. Make a table. Please make corrections to your work. Okay, please make corrections to your work. If you don't have a white piece of paper, there's a white piece of paper that's on the stand. Please pick up a white piece of paper, okay? All right, so here we go. We got the first number is 4. Okay, it says a sub 1 is 4, so that's the first number. Anytime you see this n minus 1, this is just saying that they didn't give you the zero number, they gave you the first number. That's why they have n minus 1. They did not give you the zero number, they gave you the first number. They didn't give you the starting number, they gave you the first number. Okay? So we're writing the first number is 4. Now look, this is a recursive formula. What are they telling you to do? Read the instructions. They're saying 1/2 times the number. So you're going to multiply by half to get the next number. That's all this is saying right here. Multiply by half to get the next number. So the second number, if I'm multiplying 4 times a half, what does that give me? 2. Half of 4 is 2. Okay, what's the y'all. What's the next number gonna be? It's 1. What's the next number gonna be? 1/2, 0.5 or 1/2, And our answer choices are the in fractions, so let's keep them in fractions. The fifth number, what's that going to be? 1/4. Okay, we cut this in half. Half of a half is 1/4. What's half of 1/4? 1/8. What's half of 1/8? 1/16. And I think that's what they're asking for. They're asking for the seventh number in the list. So the seventh number in the list is 1/16. That's A. Did anybody get this one right? Okay, good deal. Oh, great job. Number 19. Okay, number 19. Anybody still copying before I move? You copy. Let me pause. All right. Number 19 says the frequencies for a certain note are shown in the table. This is the note. These are the frequencies. Okay. It says if the frequencies is a geometric, that means you're multiplying to get to the next number. Geometric sequence is exponential function. What is the value of the common ratio? Rounded to the nearest hundredths place, 2 spaces behind the decimal. So you have to figure out what is being multiplied to get the next number. So let's work backwards and divide to see what number is being multiplied to get to the next number. So I'm going to use the second number. I'm going to say 466.16 divided by, work backwards, the number previous is 44.00. Let's type this in and see what number was being multiplied to get to the next number. So this is 466.16 divided by 440. And what does that give us? Very good. That gives us 1.6. And we rounded it, right? We rounded to the nearest hundredths place, so that's 1.06. 1.06. What answer choice is that?
C.
That's C. Okay. 20. Anybody still copying? Okay. Number 20. It says Terrence's spending account balance is represented by this formula right here. This is an exponential function because it's to the t power. Okay. This is your starting amount. Write this out. What's that? A of F, which is the same as saying Y. It's equal to, what's that, 100? And then in parentheses, they have, are they losing or gaining? Losing. How do you know they're losing? Very good, because this number right here is less than 1. Excellent job. That's decay. All right, so now they want to know, they said where T is the elapsed time each week, what is the balance after 2 weeks? Okay, so T represents the time in weeks. All right, so all you have to do is substitute 2 in the place of, for what? T. So 100 times 0.9 to the 2 power. So I'll type that in. 100 times 0.9 caret key 2. And what does that give you?
81.
That gives you 81. Okay. What letter is that?
C.
That's C. Okay. Any questions? Anybody raise your hand if you got that right. Okay. Good.
C's always right.
Yeah, right. No.
Yeah.
You would have got a whole bunch of.
Been C.
All right, keep going. 21. All right. So look at this. It says at the end of 2006, the population of Riverside was 400 people. Okay. The population for the small town can be modeled with the following equation, where T represents the number of years since 2006. So 2006 is going to be the starting year. Okay. P represents the number of people. Okay. So the starting population is 400. Is the population increasing or decreasing? How do you know it's increasing? Because B is greater than what number? It's greater than 1. Okay, good deal. Let me find my sheet. All right, so we're going to put 21. It says, based on this model, approximately what is the increase in the population. So you want to find the increase in the population at the end of 2009. So let's use the equation to figure out what is the amount in 2009, then find the increase amount. So use the equation. P is equal to 400 times 1.2 to the t power. What's t going to be?
3.
3. How do we get 3?
2006 minus 2009. 2009.
Very good. It's 3 years away, right? It's 3 years after the fact. So now let's figure out what that amount is for 2009. So let's type that in. We got 400 times, wrong thing, 1.2 caret key 3. What's the population there? 691.2. Okay. And what was the original?
400.
So what was the increase? How do you figure out what the increase was? Minus the 400. And so how much did it increase by? 291.2 or whatever. So what is 291? So which answer choice is the best one? A. Any questions? Do you see how they had both answers down there? Okay, so we really got to read. Questions about how we got A. Did anybody get that right on their own?
I guess.
You guess. Oh, let's not. Right. Then put your hands down if you guess.
I got it right.
Shh, no, I don't want to know. All right, keep it to yourself. A scientist conducted an experiment to observe the half-life. Half-life is at what point is the dosage reduced by half? So if the dosage is 100 milliliters, at what point is it going to be 50? Because 50 is half of 100. So anytime you see half-life, it's going to be at what point is it going to be half of what it originally started with? Let me pause for the pause. Okay, so here with number 22, scientists conducted an experiment to observe the half-life period of radioactive element for barium. It says he started the experiment with this many grams, okay, and he records the mass for the end of the 13th day. So the thing that we need to do is figure out what the equation is, because then it's asking us at what point is it going to be all the way at 1.5 grams. So we need to write the equation for this. The best way to write the equation for this, because it's not telling us, it's skipping days. You see how it's skipping days? So it's going to be hard to see how much it's going up by if it's skipping days. So we're going to type this in the calculator and allow the calculator to give us an equation. So where do I go in the calculator? I'm going to clear my calculator first. 2 plus 7, 1, 2. Where do I go in the calculator to type in table values and then find the equation? Y equals, you already have to have the equation. And wrong. Second graph is where you are viewing the function table. You don't have a function table. Stat and edit. This is where you go to enter in the table values. Stat, edit. So let's enter in the table values, please. Please do this with me, because that's why we sometimes don't do well, because we just watch me do it and we don't do it on our own. Type this in, okay? Okay. Don't get so defensive, poor thing. Okay. Type in your Y values. Okay. Type them all in. Any questions about where to go? Second, stat. Okay. Oh, well, actually, stat and then edit. Sorry. Press the stat button and then press enter on edit. Where do I go from here? I go back to stat. Good job. Calc. Expo Reg. Okay, now when you go to Expo Reg, you want to take the equation and you want to be able to look at the table values. So you need to type in second 1, comma, second 2, comma, where do you go? No. Bars. Who said that? Good job. Bars. Then Y bars, then what? Enter 3 times. You see how I'm going to put it right here in Y1. Okay, so look. So remember, I need to probably record that part again. So when you do this, you got y equals, the equation is there. You go to second graph, okay? You can stroll up and down, or look, don't forget that you can do this. Put it on, if it's on auto, look at what it's going to look like, this. Okay, you can stroll up and down and look for the value. What are we trying to look for? When it gets close to 105, and you have to keep going down till it gets to 105, till this gets to 105. Or you can type in your own x values by going to x, go back to second graph, and you type in the x values. 13, 65, 91, 104. Okay, and this right here is the one that is closest to 1.5. Okay, that is letter C. Number 23. It says, what is the y-intercept? Some of us just look at this and say it's 1. It is not 1. Because you have this -7 here. So in order always to get this problem right, anytime you're looking for the y-intercept, your x value is what? 0. No, x is 0. Anytime it's on the y-axis, your x values here are 0. So you're going to substitute 0 into the equation. So the equation is f of x is equal to 3 over 2, and you're going to plug in 0 for x minus 7. What's any number raised to the 0 power?
1.
It is 1. What's 1 minus 7? -6 is your y-intercept. That is letter what? B. Any questions about? All right. The population growth for a species of birds in the thousands can be represented by this function right here, where t is the number of years since 2002. All right. So for this one right here, you got to figure out what your you got to find the ordered pairs for 2004 and 2007. Okay. So let's do that. So let's find 2004 first. The starting year was 2002. So what are we going to type in for our x value for 2004? It's 2. So we have we have 20 times 1.24, and this is to the 2. This is for 2004. And what about for 2007? What we're going to type in for x? 5. How do we know it's 5? Because it's 5 years after. So let's figure out what these two answers are. This ordered pair is going to be 2, comma, whatever this is equal to. And this ordered pair is going to be 5, comma, whatever this is equal to. So we got 2 ordered pairs. Let's do this first one. We got 20 parentheses 1.24 caret key 2. What does that give us for 2002?
752.
Very good. So let's put that in here. This is 30.752. Now let's do this one for 5 years. We got 20 parentheses 1.24 caret key what? And how much is that? 58.63. Okay. So now we want to find the rate of change. It's x1, y1, x2, y2. So what formula do we use to find the rate of change here?
Y2
Y2
minus Y1. Yeah. X1 over. Yeah.
Okay. Any questions about that part? Y'all okay with that?
Is it always minus?
For slope? Yeah.
Okay, I thought so.
Okay. Let me 24 is 9.3.